Hey guys, welcome again to the Maths Club. If you're just joining us, welcome. Today we're going to be looking at conversion of numbers with unknown base to base 10. This is in continuation with our series in number and numerations with a specific focus on number bases that we've been treating so far. So if you need more information about the prior videos to this, you can check the pop-up link that will appear at the top of the video right now. So let's get started. As always, we're going to solve questions to actually understand these concepts. So what do we mean by unknown base? Let's see an example. Look at this question. So we're told if 104 base x is equal to 68. So when you see 68 like this, what base do you think it is in? Correct, is in base 10, right? So if no base is specified in questions like this, you can assume that it's in base 10. So we're told to find the value of x, right? So x is a number that is unknown, right? So that means that this is an unknown base, and we're equating it to 68. We said when we convert this number, right, to this unknown base to base 10, it's going to give us 68. So we want to find the value of x. Let's solve it and see. So the question is 104 base x is equal to 68, and 68 is in base 10. Basically, what I will just do is that I will just convert this 104 base x to base 10, and I will equate the answer to 68, and then I should be able to find the value of x. So following from the previous video that we did about converting from a base to base 10, we said we multiply each of the digits by the base, which in this case is x, plus 0 times x, plus 4 times x is equal to 68. Abi? Now, the second step that we said in the previous video was to give the base a power starting from 0, from the right to the left. So I'll give this base x a power of 0, a power of 1, and a power of 2. Right, so let's simplify. So I could say 1 times x squared plus, I told you that anything multiplied by 0 is 0, so we don't need to disturb ourselves. So can I say plus 0 plus 4 times x raised to the power 0 is what? Anything raised to the power 0 is 1. So 4 times x raised to the power 0, same thing as 4 times 1, right, is equal to 68. And I can simplify by taking care of the multiplications before the addition. 1 times x squared is x squared plus 0. This 0 is insignificant, so I'm not going to add it. Then plus 4 times 1 is 4, is equal to 68, right? Then we'll do what? We'll collect like terms. Collect like terms, right? So this plus 4 is going to meet 68, and when plus 4 crosses over to this place here, it becomes what? Minus 4. Great. So that will be x squared is equal to 68 minus 4, right? So x squared is equal to what? 64. So to find x, I have to now see square root of what? I'll take the square root. So I mean, the next this thing should be, but then put it under here. So taking the square root of both sides. Commenting for your WAEC or for your school exam is very, very important. Very, very important. It shows that you're actually the one that solved it and you knew what you were doing. So if I take the square root of x squared is equal to the square root of 64, right? This will give me x is equal to, now for this one, right, whenever you take a square root of something, you're always going to get plus or minus of the value. So this is plus or minus 8. Why is it plus or minus? So minus 8 times minus 8 is going to give me 64, Abi? And then 8 times 8 is going to give me what? 64. So you can see both the plus of the number and negative of the number squared is going to give me the 64. But in this case, when you look at the question that we're dealing with, right, can we ever have a negative base? No, we cannot have a negative base. Bases are always positive, right? So therefore we can now conclude and say, since x cannot be negative, therefore x is equal to it, and then you're done. So all we just did there was to really work on the fact that we already know how to convert to base 10. So we converted this left hand side to base 10 and equated the answer that it should have been in base 10, and then we collected like terms, and then we found the square root of both sides, right? And then we made our conclusion. That's basically how to solve this type of question when you are given an unknown base and you want to find what that base is. So to consolidate our knowledge, let's solve another example. And I advise you that you pause the video and then you try this example by yourself. Welcome back. So it says if m510 is equal to 11011 in base 2, right, or 1001011 in base 2, right, find the value of m. So let's solve that. Let me move this to another page. Wait. So we said m5 in base 10, right, is equal to 1001011 in base 2. So to solve this question, we are going to convert. This is in base 10. This is in base 2. Right? Why don't you make both of them to be in base 10? Then we confirm. So this m is a placeholder. So the answer could be something like 95, right? So the m there will be 9. The answer could be 75. The m there will be 7. Something like that. Right? So let's solve that. So if I say m5 is equal to, but let's convert this to base 10. Right? So I'll say 1 times 2 plus 0 times 2 plus 0 times 2 plus 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2. Let me just confirm. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. Great. And then give it the power from 0 from right to left. So this 0, this 1, this 2, this 3, this 4, this 5, this 6, right? I don't need to disturb myself about all these 0 0 0. So 1 times 2 raised to the power 6. What is 2 raised to the power 6? 2 raised to the power 5 is 32. Right, so 2 raised to the power 6 is 64, right? 64. So 1 times 64 plus anything multiplying by 0 is going to be 0 plus 0 plus 1 times 2 raised to the power 3. 2 raised to the power 3 is 8 plus 0 plus 1 times 2 raised to the power 1 is 1 times 2 plus 1 times 2 raised to the power 0 is 1, right? So if I do this, if I simplify this, 1 times 64 is 64. All these zeros, I'm not interested in them. Plus 1 times 8 is 8 plus 1 times 2 is 2 plus 1 times 1 is 1. So this 64 plus 8 is what? That's 72, right? 72 plus 2, that is 74. 74 plus 1, that is 75 in base 10. So m5 base 10. So if you compare this 5, this 5, this is m, this is 7. So we can say therefore m is equal to 7, right? Or another way to structure it is by saying therefore by comparison, right, m is equal to 7. So that's it about this type of question. So like I always say, base 10 is always the fundamental base. So if one is in base 10, just make 2 of them to be in base 10. When you get to answer, you just compare the places and you see what is missing. So let's solve one last question to consolidate everything that we have also been doing. And I will encourage you to actually solve the question yourself, right? So look at this question now. It says, given that 23 base n plus 123 base 4 is equal to 40, find the value of n. Like I always say, anytime you're not given the base, right, so you can assume that the base here is base 10. So I mean, I would just advise you that you pause the video and then you try it out by yourself. Make your mistakes. That's very fine. Welcome back. Right, so let's solve it together. So this is 23 subscript n plus 123 base 4 is equal to 40. 40 is the one in base 10. If anyone is in base 10, make all of them to be in base 10. So we'll make this to be in base 10. That would be 2 times n plus 3 times n, right? 0 and 1 plus 1 times 4 plus 2 times 4 plus 3 times 4. So I just converted this to base 10 and I'm converting this to base 10, and there's a plus that is joining both sides. So this will be 0, this will be 1, and this will be 2. Is equal to 40. 40 is the one in base 10. So 2 times, let's simplify. That will be 2 times n plus 3 times what? 3 times 1, great. Plus 1 times 4 squared is what? That's 16. Plus 2 times 4 raised to the power 1 is 4. Plus 3 times 4 raised to the power 0. Anything raised to the power 0 is what? Is 1, right? Is equal to 40. I encourage you to actually be solving along with me. Right? Get a pen and solve along. Don't just watch this video, solve along. That's how you actually learn. Now we can simplify. Since we already have all the power sorted out, so we can multiply, and then after multiply we can add. So this will be 2n. 2 times n is 2n. 3 times 1 is 3. Plus 1 times 16 is 16. Plus 2 times 4 is 8. Plus 3 times 1 is 3. Is equal to 40. Right? So we can still simplify further. So 2n plus 3 plus 16 is what? That is 19. 19 plus 8, that is 27. 27 plus 3. So let's see. Let's backtrack just to be sure that we didn't make any mistakes. So these 2 times n raised to the power 1 plus 3 times n raised to the power 0 plus 1 times 4 raised to the power 2 plus 2 times 4 raised to the power 1 plus 3 times plus 3 times 4 raised to the power 0. So this is 3 times 1, 2 times 4, 1 times 16, 3 times 1, 2 times n. So this 2n, this is 3, this is 16, this is 8, this is 3 is equal to 40. Okay, so 2n plus 3 plus 16 plus 8 plus 3. 3 plus 16 is 19. 19 plus 7 plus 8 is 27. 27 plus 3 is what? That's 30. Right? Is equal to 40. Right? So that's good. Sometimes I have to just go back to be sure that I didn't make any mistake. So 2n. So what are we going to do now? We're going to collect like terms. So collecting like terms. And if I want to collect like terms, so this plus 30 will go to the other side, right? It's become minus 30. So if I write, that would be 2n is equal to 40 minus 30, right? 2n is equal to what? What would this give me? 10. N is equal to, or you can say, just for pedantic purposes, right? So you divide both sides by 2. Always comment. So that will be 2n divided by 2 is equal to 10 divided by 2. So 2 will cancel 2. 2 here 1, 2 here what? 2 here 5. Therefore, n is equal to 5. Right. So you've been able to see how we were able to solve 3 different questions, right, that had unknown bases. And this one, by converting this one to base 10, we're able to find what the x is. Same thing, so by converting it to base 10, we're able to do comparison and find out what m was. By converting it to base 10, and this one to base 10, and then doing some calculations on that, we're able to find what n was. And you can see that's how we can able to find the values of these things, right? This is like the application of all the things that we've been doing before. Let's confirm if our answers are correct. The first answer that we got is 8. So let's see, were we correct? X is equal to 8. Very good. Next answer is what? 7, right? I think I said that. So by comparison, m is equal to 7. So we are good, right? And this last one, we got what? 5, right? And that was the answer that we got. N is equal to 5. Great. So with this, we've actually come to the end of this particular topic, right, of this particular concept under the topic, which is conversion of numbers with unknown base to base 10. So the part that we're going to go to next is conversion from a non-base 10 to another non-base 10 number. So that means if I want to convert from base 2 to base 4, right, or base 4 to base 2, or base 7 to base 5, right, how am I going to do that? See you guys in the next video. Don't forget to like and subscribe and comment if you have something that was unclear to you. You want maybe me to explain or something, or you want to comment what you're doing or anything, right? Don't forget to comment or to like and subscribe. See you guys in the next video.